Hi guys, welcome to Cambridge Guru. As you know that we are doing A-level pure maths paper number 32 series, and in this we have already covered 5 units. Number 1 was algebra, second is log and exponential, third is trigonometry, fourth is differentiation, and fifth was integration. Today we are going to start with new unit, which is numerical solutions of equations. So without wasting any time, let us start. If I say you, I straight away start with a question because this is the introduction of the chapter. This says that which of the following equations can be solved algebraically and which cannot. Meaning is that there are certain equations which cannot be solved algebraically or by the usual methods that we know. Right? For example, in the first part it is a quadratic equation x square minus 4x plus 3 is equal to 0. This equation, since we know the quadratic formula, there are various methods to solve any quadratic equation. One is by using the formula, which is using the discriminant b square minus 4ac. Then we can, if the equations can be factorized, we can use the factorization method, or we can use the completing the square method. Similarly, second equation can also be solved, though it doesn't matter the roots of the equations are imaginary or real, because in the second equation, which is x square plus 10x plus 8, this is having I think there is a root, but if any equation is not having any real root, then also we have arrived at a situation where we can tell that this cannot be solved. This can be solved, but the roots are not real, though they are imaginary, right? So it doesn't matter that if you are not able to find out the real roots, but the roots of the equation are complex. That means you have arrived at a situation where you have solved the equations, right? If we talk about the third equation, which is of the degree 5. Now we do not know the method, the usual or the direct method or the algebraic method that can be used to solve any equation, algebraic equation, which involves the degree 5, right? We know the methods which can be solved. We know the methods to solve a cubic equation, not just the equation which can be factorized, but other methods are also there that can be used to solve any cubic equation, right? There are methods which can be used to solve a biquadratic equation, means of the degree 4, but this equation has a degree 5 and this cannot be solved algebraically, right? If we arrive at the fourth equation, which is x cubed minus x equal to 0, this can be solved if we take out the x outside. This is x square minus 1 equal to 0. So we arrived at the solution which are x is equal to 0 and plus minus 1, right? If we talk about the fifth equation, this is an equation which involves an algebraic function which is 4x and an exponential function which is e raised to power x. Now any equation which is of the type e raised to power x and it involves an algebraic variable which is x, this cannot be solved algebraically. We have to apply certain other methods to arrive at the solution. So this chapter is about those equations, solving those equations using some indirect methods. You will be given some equations which are very complex and that cannot be solved algebraically. So we will learn in this chapter some indirect methods that can be used to solve these kinds of equations. And obviously, since these are indirect methods, the solution that they provide will be approximate. We cannot arrive at an exact solution, right? So you can take another example that if any equation of the type, let us say x square sine x plus 2x is equal to 5, you can form any equation from your from your mind or from on your own. You can use any equation, you can form any equation, because you do not know how to solve this equation, but yes, there are methods which can be used to arrive at the approximate solution of this equation also, right? But yes, there are certain conditions in these indirect method also that needs to be satisfied. Okay, so if I take these two equations, one is x raised to power 5 minus 5x plus 3, means this third part, and this fifth part, let us see what graphical calculator says about the graph of these two functions or the equations. This is the graph for x raised to power 5 minus, I think the equation was minus 5x plus 3, minus 5x plus 3. This is your function fx. And this is the graph for the function e raised to power x and 4x. Okay, we will arrive at the second one, but look at this red graph, part 1. It says that since the graph is crossing, the curve is crossing the x-axis at 3 points. One point is this, second is this, and third is this. This is 1, second, and third. Okay, I'm not saying these are the roots. Okay. Now these points, if any curve is crossing the x-axis, we know by applying the methods of polynomials that we have already studied, that if any curve is crossing the x-axis, that means these are the roots of the equation fx equal to 0. Right? You have been given any curve, let us say this quadratic curve, parabola, if I'm drawing like this, and if this value is 2 and this value is 3 and this is quadratic, so I know that there is a quadratic function whose expression is x square minus 5x plus 6, right? As you can see here that the graph is crossing the x-axis at x equal to 2 and at x equal to 3, means 2 and 3 are the roots of the equation fx is equal to 0, right? That means x square minus 5x plus 6 equal to 0 has roots 2 and 3. That means the curve is crossing at the point 2 and 3. Curve is crossing the x-axis at the points 2 and 3. So 2 and 3 are the roots of the equation fx equal to 0, right? So this is the curve for x raised to power 5 minus 5x plus 3. It is crossing the x-axis at 3 points. Okay, and using the graphic calculator, it is saying that the roots are lying between minus 2 and minus 1, 0 and 1, and 1 and 2. This root is lying between minus 2 and minus 1. This root is lying between minus 1 and plus 1, 0 and 1. And this root is lying between 1 and 2. Okay, similarly, the second graph says that e raised to power x equal to 4x has 2 roots. Now, there is a difference between the graph of part 1 and part 2. In part 1, we have drawn the graph of fx is equal to 0. But in the second part, we have drawn a graph of f1x is equal to f2x. Means there are two graphs and we are finding out the point of intersection of two different graphs. One is e raised to power x and one is 4x. Because if we are drawing the graph of fx which is equal to e raised to power x minus 4x, this graph is very complicated and cannot be drawn using usual methods, graphically also, right? So we have some indirect methods to draw the graph also, or to arrive at the solution of the point of intersection of this function which is e raised to power x minus 4x, is that you equate this equal to 0, draw graph of e raised to power x separately, draw the graph of 4x separately, and find out the point of intersection of these two graphs. That will be the roots of the equation fx which is e raised to power x minus 4x equal to 0. I hope I am making my point clear, because this you have already done in IGCSE syllabus. Okay. So the second graph says that the roots are lying, means these point of intersections are lying between 0 and 1 and 2 and 3. Okay. But how to arrive exactly at a solution? Exactly means very closer to the solution, because you cannot say that the root is lying between 0 and 1 and your work is finished. No, you have to give a certain value, and that value should be accurate. Not accurate, but approximate to the accurate value. Okay, so the work is not finished yet because you have just given the intervals. Intervals are not the solutions. Okay, you have to give certain value. Now, how to arrive at that approximate solution? The method we use is the change of sign method. I will take the same graph, which is fx equal to x square minus 5x plus 6. As you can see here, that if I am moving from minus infinity towards right, okay, the moment I arrived at x equal to 2, the graph is changing the sign from positive to negative. Graph is moving from plus to minus, okay, in this direction. And we arrived at a solution, we arrived at a root which is x equal to 2. Right? Again, if I move from 2 to 3 and goes beyond 3, you will say that the graph changes its sign from negative to positive. And here the graph is changing its sign from positive to negative. Okay? That means if a graph is changing its sign from positive to negative or from negative to positive, that means there is a root that is lying between these two values, or there is a root that is lying between these two values of fx. Okay, so at x equal to, so for all the values of x which are less than 2, function is positive. For all the values of x which are greater than 2, function is negative. So that means the root is x equal to 2. Same concept applies to this point x equal to 3. So roots are 2 and 3, right? So the method is change of sign method. If you are able to draw a sketch or find out that the value of the function is changing its sign either from positive to negative or from negative to positive as we move from the lower value to the higher value of the interval, right? That means the root is lying between those two values. Okay, if I say that for this function x square minus 5x plus 6, if I take, let us say, an interval between 1 and let us say between 0 and 1, you put x equal to 0 here, you will get value as plus 6. You put x equal to 1 here, which is positive. You put x equal to 1 here, again you will get a value which is 7 minus 5 is 2. It is again 0. That means between this interval the sign is not changing, okay, of the function. Sign of the function remains positive. That means there is no root lying between 0 and 1. But if you take any value, if you take the value between 1 and 3, you put x equal to 1 here, you will get 1 plus 6 is 7 minus 2, it is positive. And if you take a value which is, let us say, 2.5, you will get a negative value, because as we can see here that between 2 and 3 the value of the function, let us say at x equal to 2.5, value is negative. So root is definitely lying between 1 and 2.5, which is in this case exactly is 2, right? So what change of sign method is saying, I'm again repeating, that you just put the extreme values of the interval, find out the values, not just the values, but just to look at the sign of the function. If the sign changes from positive to negative or from negative to positive, that means root is lying between those two values of the interval. So let us take our example, which was x raised to power 5 minus 5x plus 3. This one. Okay. So here the graph is changing from negative to positive. So this is the root which is lying between a and b. And here the graph is changing its sign from negative to positive. Again, there is a root which is lying between a and b. Okay, so only these are the two possibilities to give an estimate of the interval, right? So here one method is decimal search method in order to arrive at the approximate value of that root, right? We have the function which is x raised to power 5 minus 5x plus 3 equal to, not equal to 0, just the value of the function I am saying. Okay. Now initially it was saying that since a root is lying between 0 and 1, as you can see here, one root is lying between 0 and 1. So we take out this interval in order to just explain the change of sign method. Okay. And within that change of sign method, one method is decimal search method. Okay. So we pick up this interval which is 0 and 1 and see what this decimal search method says. It says that at x equal to 0, the value of the function is positive, which is 3. Right? At x equal to 0.1 means you keep on increasing now the interval from 0 to 0.1, then from 0.1 to 0.2, means now you are moving from 0 to 1. Okay, as the interval is 0 to 1, you are moving from 0 to 1 by increasing the value of the x value by 0.1. Okay, so this is 0.1, value is 2.5, 0.2 it is 2, 0.3 it is 1.5, at x equal to 0.4 it is 1.01, and as you arrive at x equal to 0.7, the sign of the function changes from positive to negative. Means the value of the function is 0.08, it changes to minus 0.33 at a point which is lying between 0.6 and 0.7. Now, what is the use of this? That initially the interval was 0 and 1, right? It is 10 decimal point apart. Now, applying this change of sign method, you have reduced this interval from 0 to 1 to 0.6 to 0.7. From 0 to 1 to 0.6 and 0.7 because the sign of the function is changing from positive to negative. Now, in order to arrive at a more accurate value, you again increase or reduce this interval to 0.01, right? So again increase, you move from 0.6 to 0.7 by increasing the value of the x by 0.01. So let us see what's the value of the function will change, how the value of the function will change. So at x equal to 0.6 it is 0.08, at 0.61 it is 0.03, and at 0.62 the value is negative. So it indicates that again the root is lying between 0.61 and 0.62, means it is more closer to 0.6. 0.7 is very far, it is more closer to 0.6, right? So again you have reduced the interval to 0.61 to 0.62. Okay, now it depends on you that if you want to give more accurate value, you can again increase the value of the interval by 0.1, right? Means 0.001, sorry. Okay, so next value you can take as 0.61 plus means 0.611, then 0.612, 0.613, and so on, and see where the sign of the function is changing. Okay, so we are stopping here, and we can say that approximately you can take the mid value of this, which is 0.615, right? So you can say that approximately the solution of this equation, since it is lying between 0.61 and 0.62, let us take a mid value of this interval, which is 0.615. That is your approximate solution of this equation. Okay, same thing you can do for e raised to power x minus 4x. The second function was e raised to power x is equal to 4x. You can form a function fx which is e raised to power x minus 4x and estimate the value of the interval. Start putting 0 and 1 and see whether the root is lying between 0 and 1 or any other interval which is not 0 and 1. Okay, this is the first method, which is decimal search method. Let us look at the second method, which is called the bisection method. What this interval bisection method says, that instead of increasing the interval from lower value to higher value by 0.1, which is called decimal search, you just bisect the interval initially. Okay, so for the same function x raised to power 5 minus 5x plus 3 equal to 0, if you are estimating the value between 0 and 1, because initially we knew that the root is lying between 0 and 1, so what you do is you bisect this method, bisect this interval into 0 and 0.5 and plus 0.5 to not 0.1, 0.5 to 1. Okay, now find out the value of the function at 0.5. Okay, 0, we know that at x equal to 0 function is positive. At x equal to 0.5 the function is again will come out to be positive, because initially in the decimal search method we have arrived that it is greater than 0.6. Okay, so you will look at the interval 0.5 and 0.1 and again keep on bisecting this value. Find out the midpoint of 0.5 and 1, which is 0.75, and then see the value of the function at 0.5 and 0.75. If the sign of the function is coming out to be same for x equal to 0.5 and 0.75, then go for the next interval, because it will show the graph will change its sign not from 0.5 to 0.7 but from 0.75 to 1. Okay, so if you remember the logic why the sign change of the function gives you the root. If you remember those two graphs from negative to positive or from positive to negative, you will see, you will understand what these interval bisection and decimal search method really talk about. In the next video, we will solve some questions on interval bisection and decimal search method, and we will estimate whether the root really exists between the given intervals or not. Okay, thank you for watching.